Preparing for a Docker security engineering interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What are the main security risks associated with running Docker containers? Docker reduces packaging friction, but it does not automatically create a security boundary. I evaluate vulnerable images, excessive Linux capabilities, privileged containers, exposed sockets, secret leakage, unsafe mounts, and kernel escape risks. I harden the host, scan images, use least privilege, enforce resource limits, protect registries, and monitor runtime behavior. My threat model distinguishes container compromise from host compromise, because a container is typically a process isolated by the host kernel, not a separate virtual machine. While answering, discuss image vulnerabilities, container escape, excessive privileges, exposed Docker sockets, insecure registries, secrets leakage, weak isolation, host compromise, supply chain threats, and the importance of defense in depth. Question 2. How would you secure a Dockerfile used in production? I start from a trusted, minimal, digest pinned base image and use multi-stage builds so compilers and package managers stay out of production. I create a dedicated non-root user, remove unnecessary packages, set restrictive file permissions, and avoid copying credentials into layers. Secrets belong in build kit. Secret mounts are the deployment platform, never arg or env values. I also generate a software bill of materials, scan the final image, and rebuild regularly for patched dependencies. Make sure to cover trusted minimal base images, pinned digests, non-root users, multi-stage builds, secret handling, reduced packages, explicit permissions, vulnerability scanning, health check considerations, and reproducible build practices. Question 3. Why should containers generally not run as root, and how do you enforce that? Container root is not automatically host root, but it has more authority than necessary and can exploit misconfigurations or kernel vulnerabilities. I create an explicit application user in the image, set user, and verify ownership of required files. At runtime, I use user drop capabilities, enable no new privileges, and enforce policies that reject root containers. Rootless Docker or user namespaces provide stronger protection, although compatibility and networking can require careful testing. In your answer, explain container root versus host root, UID mapping, privilege escalation, Dockerfile user, runtime flags, rootless mode, admission policies, file system permissions, and exceptions requiring documented risk acceptance. Question 4. What is Docker rootless mode, and what security benefits and limitations does it have? Rootless mode runs both the Docker daemon and containers as an unprivileged user, using user namespaces to map container identities safely. A compromised container therefore has less opportunity to affect the host than with a rootful daemon. The trade-offs include limited privileged ports, networking differences, storage driver constraints, and possible performance overhead. I still apply image scanning, capability reduction, Seccomp, and monitoring because rootless mode reduces impact but does not eliminate application vulnerabilities. Be sure to mention user namespaces, daemon privileges, reduced host impact, subordinate UID ranges, networking and storage limitations, performance considerations, and when rootless mode should complement rather than replace other controls. Question 5. How do Linux namespaces and cgroups contribute to Docker container security? Namespaces provide separated views of system resources, process IDs, networking, mounts, users, IPC, and host names. Cgroups control resource consumption such as CPU, memory, and process counts. Together they isolate workloads and reduce denial of service risk, but they share the host kernel, unlike virtual machines. I treat namespaces as isolation controls and cgroups as resource governance controls, then strengthen both with Seccomp capabilities, read-only file systems, patched kernels, and runtime monitoring. Focus on namespace isolation for processes, networking, mounts, users, and IPC. cgroups for CPU, memory, and process limits, kernel dependency, escape possibilities, and why isolation and resource governance solve different problems. Question 6. What are Linux capabilities, and how would you minimize them in a container? Capabilities divide traditional root privileges into smaller units. Instead of granting full root authority, I drop all capabilities and add only what the application demonstrably needs. For example, a web server might require none, while a network tool could need NETRAW. I pay special attention to powerful privileges such as sysadmin, SYSPTRACE, and NETADMIN. I test functionality under the reduced set, document exceptions, and combine capability controls with no new privileges and Seccomp. In your answer, define capabilities as granular privileges, distinguish default from dangerous capabilities, explain cap drop and cap add, mention CAPSYSADMIN and NETADMIN, and validate application behavior before granting exceptions. Question 7. How do Seccomp and AppArmor or SELinux protect Docker containers? Seccomp restricts the system calls a container can make, reducing kernel attack surface, while AppArmor or SELinux applies mandatory access control rules to files, capabilities, and operations. I begin with maintained default profiles, then create narrowly tailored policies from observed application behavior. I test denials in staging and monitor policy violations before production rollout. These controls are valuable compensating barriers, but they should complement patched images, least privilege, and secure application design. Make sure to explain syscall filtering, mandatory access control, default profiles, custom policies, denial troubleshooting, policy testing, and the fact that these controls contain behavior rather than fixing vulnerable application code. Question 8. How would you prevent secrets from leaking during Docker builds and runtime? I never place credentials in Dockerfile arg, env, source code, or copied configuration, because values can remain in image history or layers. For builds, I use build-kit secret mounts so credentials are available only during the required command. At runtime, I inject short-lived secrets from a cloud secret manager or orchestrator, restrict access, rotate them, and prevent accidental logging. I also scan repositories, layers, logs, and artifacts, because leakage often occurs outside the container itself. Discuss why arg and env are unsafe for secrets, build-kit secret mounts, runtime secret managers, logs, image history, mounted files, rotation, access scope, and avoiding secrets in source control or generated artifacts. Question 9. How would you design a secure Docker image supply chain? I establish trusted base image sources, pin dependencies and image digests, and build in isolated, ephemeral workers. The pipeline produces an SBOM and provenance attestation, scans operating system and application packages, signs approved images, and verifies signatures before deployment. Registry permissions are tightly scoped, and only immutable, reviewed tags move toward production. I continuously rescan because a clean image today may become vulnerable tomorrow, then trigger rebuilds, rollback, or quarantine based on severity and exploitability. Cover trusted sources, immutable digests, dependency pinning, SBOMs, vulnerability scanning, signature verification, provenance attestations, isolated builders, review gates, registry controls, and rapid revocation or rebuild procedures. Question 10. What is Docker Content Trust, and what problem does image signing solve? Image signing lets a consumer verify that an image came from an authorized publisher and was not altered after publication. Docker Content Trust uses signed metadata to protect tag integrity, while modern workflows may use tools such as cosign and sigstore. I enforce verification in C and deployment policy, protect signing keys with dedicated identity or hardware-backed storage, and rotate them carefully. Signing proves provenance and integrity, it does not prove the image contains no vulnerabilities. Be sure to explain authenticity, integrity, publisher verification, signed tags, trust metadata, key management, limitations around vulnerability status, deployment enforcement, and the distinction between signing an image and proving it is safe. Question 11. How would you secure communication between Docker containers? I place services on dedicated user-defined networks and expose only the ports that clients genuinely require. I avoid publishing internal ports to the host and separate front-end, application, and data plane traffic. For sensitive communication, I use TLS, preferably mutual TLS with managed certificate rotation. In orchestrated environments, I add network policies and service identity. I also authenticate every request because network membership alone is not a sufficient trust boundary. In your answer, cover user-defined networks, segmentation, exposed versus published ports, service discovery, encryption, mutual TLS, network policies, least privilege connectivity, DNS risks, and avoiding trust based solely on network location. Question 12. What risks are created by mounting the Docker socket into a container? The Docker socket effectively grants control over the Docker daemon. A process with access can create privileged containers, mount the host file system, and usually gain host-level control. A read-only socket mount is not sufficient because clients can still issue mutating API requests. I avoid the mount, use remote builders or dedicated APIs, and isolate crunners. If unavoidable, I apply a narrowly scoped proxy, strong authorization, short-lived credentials, and dedicated disposable hosts. Discuss the socket as a privileged control interface, daemon compromise, host file system access, crunner exposure, safer alternatives, socket proxies, authorization controls, and why read-only mounting does not make the interface safe. Question 13. How would you investigate a suspected container escape? I first isolate the host from production networks without destroying evidence, then stop scheduling new workloads and preserve container, daemon, kernel, audit, and registry logs. I examine privileged flags, capabilities, mounts, namespaces, suspicious syscalls, processes, and image provenance. Credentials exposed to the workload are revoked immediately. I rebuild from trusted sources rather than cleaning in place, patch the host, validate neighboring systems, and conduct a root cause review before restoring service. Make sure to cover containment, evidence preservation, host isolation, runtime and kernel telemetry, image provenance, privileged settings, namespaces, capabilities, mounts, affected credentials, eradication, recovery, and post-incident hardening. Question 14. Which Docker runtime security controls would you apply to a high-risk workload? For a high-risk workload, I run as a non-root UID with a read-only root file system and explicitly mounted writable paths using TMPFS where possible. I drop all capabilities, enable no new privileges, apply Seccomp and a mandatory access control profile, and set CPU, memory, PID, and file descriptor limits. I isolate its network access, use a minimal signed image, and collect runtime telemetry. The exact profile comes from tested application requirements, not blanket exceptions. Cover non-root execution, read-only root file systems, dropped capabilities, Seccomp, AppArmor or SELinux, no new privileges, resource limits, temporary file systems, isolated networks, and monitoring for policy violations. Question 15. How do you handle vulnerabilities discovered in a production Docker image? I identify every deployment using the vulnerable digest, then assess severity, exploitability, exposure, and compensating controls rather than relying only on a scanner score. I patch the dependency or base image, rebuild from source, rescan, sign, and deploy the replacement through a controlled rollout. For active exploitation, I may isolate workloads or block traffic first. I document exceptions with expiration dates, verify remediation independently, and improve update automation afterward. Discuss severity and exploitability assessment, affected deployment inventory, temporary mitigation, patching and rebuilding, scanning limitations, emergency rollback, communication, exceptions, verification, and preventing recurrence through automated lifecycle management. Question 16. What is the difference between Docker image scanning and runtime security monitoring? Image scanning analyzes static content such as operating system packages, libraries, manifests, and sometimes configuration before deployment. Runtime monitoring observes actual behavior, including unexpected processes, file changes, network connections, privilege use, and suspicious syscalls. Scanning can miss 0 days and application flaws, while runtime tools can miss dormant vulnerabilities and create behavioral noise. I combine both, correlate findings with image digests and SBOMs, prioritize exploitable risk, and feed results into prevention and incident response. In your answer, distinguish static package and configuration analysis from behavioral detection, explain false positives and blind spots, mention SBOM correlation, syscall and process telemetry, and show why both controls are necessary. Question 17. How would you secure a Docker-based CI/CD pipeline? I use ephemeral, isolated runners so one build cannot persistently compromise another, especially for pull requests from untrusted contributors. Build credentials are short-lived and scoped, and secrets are unavailable unless a trusted workflow requires them. I protect branches, pin actions and dependencies, control cache usage, scan and sign artifacts, generate provenance, and verify images before deployment. Registry push permissions stay separate from runtime pull permissions, limiting blast radius across the pipeline. Focus on isolated ephemeral runners, untrusted build handling, least privilege tokens, protected branches, dependency controls, secret isolation, artifact signing, provenance, cache poisoning, registry permissions, and deployment verification. Question 18. What security considerations apply to Docker volumes and bind mounts? A bind mount can expose sensitive host files or allow a compromised container to modify them, especially when writable. I prefer named volumes or external storage, mount paths read only whenever possible, and never expose Docker configuration, host devices, or broad file system routes. I define ownership and SELinux labels deliberately, restrict sharing between containers, and protect backups and snapshots. For host integration, I document the narrowest required path and validate mount propagation settings. Be sure to mention host file system exposure, writable versus read-only mounts, sensitive paths, ownership and labels, volume lifecycle, backup protection, container sharing, propagation modes, and safer data access patterns. Question 19. How would you threat model a multi-tenant Docker host? I assume one tenant may be malicious and ask whether a shared kernel provides adequate isolation for the data sensitivity and threat capability involved. I separate tenants by hosts or stronger VM boundaries when necessary, prohibit socket access and privileged mode, enforce resource quotas, isolate networks, and restrict metadata and mounts. I patch kernels rapidly and monitor cross-container behavior. Containers are efficient for cooperative workloads. Hostile multi-tenancy often justifies micro-VMs or dedicated infrastructure. Discuss tenant isolation assumptions, shared kernel risk, malicious workloads, noisy neighbors, daemon and socket access, metadata exposure, network segmentation, dedicated hosts, runtime policies, monitoring, and when virtual machines are more appropriate. Question 20. How would you build a security baseline for Docker across an engineering organization? I create a practical baseline covering hardened hosts, protected daemons, approved digest pinned images, non-root execution, dropped capabilities, Seccomp, resource limits, secret controls, scanning, signing, and runtime monitoring. C enforces mandatory checks, while deployment policy blocks high-risk configurations. Exceptions require an owner, rationale, compensating control, and expiration. I publish reusable templates and secure defaults so developers can comply easily, then measure coverage, remediation time, incidents, and policy drift. Cover policy ownership, sys-style controls, approved images, non-root defaults, scanning and signing, daemon and host hardening, exception management, developer usability, telemetry, audits, and measurable continuous improvement. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.